Hello students, we already discussed about coherent sources, incoherent sources, superposition principle. In this module, we will discuss about interference of light in detail. You have seen that when waves interfere each other, we will get alternate bright and dark points. These bright and dark points we call as fringes. Here we are going to discuss what is the intensity of the bright fringe, what is the fringe width of bright and dark fringes. What is meant by interference of light? The phenomena of redistribution of light energy due to the superposition of light from two coherent sources is known as interference of light. Here S1 and S2 are two coherent sources. What will be the condition for constructive interference and destructive interference when the waves from S1 and S2 superimpose each other? Here we are going to derive the condition for constructive and destructive interference. Waves produced from S1, that is Y1 is equal to A cos omega t, and from S2, that is Y2 is equal to A cos omega t plus phi. When these two waves superimpose each other, that means the resultant wave Y is equal to Y1 plus Y2. But here, what is Y1? Y1 is the displacement of the wave at any instant of time t. And Y2 is the displacement of the other wave at any instant of time t. A is the amplitude of the first wave and here A is the amplitude of the second wave. Omega is the angular frequency. Phi is the phase difference between the waves from S1 and S2. Now we will see what happens when these two waves superimpose each other. See, when these two waves superimpose each other, Y is equal to Y1 plus Y2. That is A cos omega t plus A cos omega t plus phi. That is 2A cos omega t plus phi by 2 cos phi by 2. Here we use the trigonometric relation cos c plus cos t, that is 2 cos c plus d by 2 cos c minus d by 2. C is omega t and D is omega t plus phi. So we use the relation. So got it, 2A cos omega t plus phi by 2 and cos phi by 2. Now we know that here we are getting cos minus phi by 2, but cos minus theta is cos theta only. So cos minus phi by 2 we can write cos phi by 2. So we got the final relation. Y is equal to 2A cos phi by 2 cos omega t plus phi by 2. This cos omega t plus phi by 2, this is the time function, and 2A cos phi by 2, this is a constant. So 2A cos phi by 2 is the amplitude of the resultant wave. You know that intensity is equal to square of the amplitude. That is I is equal to A square, that is 4A square cos square phi by 2. Now when phi is equal to 2n pi, that is phi is equal to 0, then what we will get? Cos 0 is equal to 1, that is 4A square. Then phi is equal to 2n pi, that is n is equal to 1, then it will be coming 2 pi. Phi is equal to 2 pi, 2 pi by 2, that is pi. Cos pi minus 1, cos square pi is 1, then again 4A square. That means we can say that intensity is maximum only when phi is equal to 2n pi. The value of n is from 0 to infinity. When phi is equal to 2n plus 1 into pi, that time I is equal to 0. This is the minimum intensity, that is the dark point. minimum intensity. Then you can see that here n is equal to 0, that means it coming pi, that is cos pi by 2, that is equal to 0. Cos 3 pi by 2, 0. Here n value is from 0 to infinity. Now we can rearrange this by using the trigonometric relation, that is I is equal to 4a square cos square 5 by 2. You know that cos square 5 by 2 we can write 1 plus cos 5 by 2. This is the one trigonometric relation, multiple angle relation. So when you rearrange it, you will get the final formula I is equal to I1 plus I2 plus 2 root I1 I2 cos 5. Root I1 root I2 then cos 5. Here I1 is the intensity of the first wave. Here first wave means A cos omega t, that A is the intensity, that is I1 is equal to A square. Then I2 is also A square. Then we write in place of A square, that is I1. Then next A square I2, that is I1 plus I2 plus 2 root I1 I2 cos 5. Now see I is equal to I1 plus I2 plus 2 root I1 I2 cos 5. When phi is equal to 2n pi, n is equal to 0 to infinity, that time I1 plus I2 plus 2 root I1 I2 we got it. So this is the maximum value of the intensity, that is I max is equal to root of I1 plus root I2 the whole square. When phi is equal to 2n plus 1 into pi, that time what happened, this become I1 plus I2 minus 2 root I1 I2, because there phi become minus, that is another relation we already discussed it. Then I max upon I minimum, that is root of I1 plus root I2 the whole square minus root I1 minus I2 the whole square. That is we can write I1 is equal to A1 square I2 A2 square, then I1 by I2, that is A1 square by A2 square, that is equal to W1 by W2. Actually W1 is the width of the first source and W2 is the width of the second source. So this is the intensity. The intensity for the maximum, that is I max, that is I1 plus I2 plus 2 root I1 I2. This cos phi is positive, we will get this value. When the cos phi become negative, that way you are getting this value. That is the condition for maximum and minimum according to that. What is the relation between phase difference and path difference? We have seen that what is the phase difference when the waves interfere constructively and destructively. Here lambda is the path difference and phase difference is 2 pi. You know that one complete wave motion, that is wavelength, that is lambda. Then the complete circular motion, that is 2 pi. So wave motion and circular motion we are relating here, that is the lambda and 2 pi. Then what is the phase difference? Phase difference phi is equal to 2 pi by lambda into path difference. Then the path difference is equal to lambda by 2 pi into phase difference. Now we'll see the relation between path difference and phase difference. Here phi is equal to 2n pi. Then what is the path difference? That is lambda by 2 pi into 2n pi, that is delta is equal to n lambda. This is the condition for constructive interference. Here n is equal to 0, 1 to infinity. Don't forget this one. Then for a destructive interference, phi is equal to 2n plus 1 into pi, that you know it. Then path difference delta is equal to lambda by 2 pi into 2n plus 1 into pi. that is 2n plus 1 into lambda by 2, that is n is equal to 0, 1, 2, 3 to infinity in that case. Then otherwise delta is equal to 2n minus 1 into lambda by 2, then n is equal to 1, 2, 3 to infinity. So this is the condition for constructive interference and destructive interference. Constructive interference, the path difference is equal to n lambda and phase difference phi is equal to 2n pi. Then for a destructive interference, path difference is equal to 2n plus 1 into lambda by 2 and phase difference is equal to 2n plus 1 into pi.